Hey guys, Mr. Ray here with our next math lesson, grade 10 academic. If you remember the last lesson we learned about the tangent ratio, okay? And we used this for right triangles. We were able to, if you think back, we were able to, if we knew the opposite and hypotenuse, opposite and adjacent side, we would be able to figure out what angle that is in the triangle. So knowing those two sides would give us allow us to get that angle. Now the reason why we started with this choice of sides was opposite over adjacent is really the same as well, it's the same as slope, rise over run. So the tangent ratio, we also, that could be called the slope ratio. We don't usually call it that, but it's directly related to slope. Okay, so the tangent ratio is the slope. Okay, now we're also able, if we knew the angle of a triangle and one of these two sides, we would be able to get the other side by using the tangent inverse function. Okay, so hopefully you remember that from the last lesson. What we're going to do today is, here's the big news. There are other trigonometric or trig ratios. Okay, and those two ratios are called the sine and the cosine ratios. So why do we have these? Well, what would maybe we don't always are given these two sides. Maybe we're given these two sides, hypotenuse and opposite, or maybe hypotenuse and adjacent. Well, how would we find the angle if we didn't have both opposite and adjacent? Well, in reality, you could figure out the third side because it's a right triangle. You could use Pythagorean theorem, but that's like an extra step. So we have these two other ratios that allow you to solve for missing sides or unknown angles of a triangle if you know any combination of two of these sides or one side and the angle. So so the actual words are sine, they're written sine and cosine, but you'll notice on your calculator it's been shortened to three letters, so SIN and COS. So now when you go into grade 11, please don't say this is the sin ratio. This is sine. Okay, it's just a short version of sine, so it's the same word. And cos would be how you pronounce this. So sine and cos and tan are the three ratios. Okay, now here's the actual sine ratio is defined as the sine of an angle is the opposite side over the hypotenuse. Remember, tan ratio is opposite over adjacent. This is opposite over hypotenuse. Okay, so if you know these two sides, you could use the sine ratio to get the angle. Okay, and so that takes care of two of the three combinations, and then the third combination would be adjacent hypotenuse, and that's where the cosine ratio comes in. Okay, so you'll see why we do this in a minute. Okay. We call these three ratios the primary trig ratios. Okay, so there's three ratios. Now, part of the problem, and I've always had a tough time remembering, what's the sine ratio? What are the sides for the sine ratio again? Well, this is a really good little tool. It's one of the only things I ever memorized in math to help me, and it's this word here. Okay, it's not really a word. Sohcahtoa. Okay, so if you say it out, you have to phonetically enunciate it very carefully, otherwise you'll get mixed up. Sohcahtoa. Okay, so if you break it up into three parts, it actually defines what these three ratios. For example, SOH means sine is equal to opposite over hypotenuse. Okay, and cosine would be adjacent over hypotenuse. Hold on, let me start that again. All right, so there's the word Sohcahtoa. So you break it down into three parts, three-letter acronyms. SOH actually means sine is equal to opposite over hypotenuse. CAH means cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So if you just remember that word, you know that the first letter is SC or T because of sine, cosine, and tan, and then the second and third are the sides that you would use in the correct order. So Sohcahtoa. Okay, so now just like we had a tan inverse function to figure out the angle if we knew the opposite adjacent side. What's the angle? We use tan inverse, but we also have inverse for cosine and sine, and we call them cosine inverse and sine inverse. Okay, we'll see how those are on your calculator, but basically most calculators it's the same key as cosine and sine. It's just the second function or some color-coded key that you press first to get it. All right. So we use these trig ratios either to find a missing side length of the triangle or to determine the exact measurement of the angle using the trig ratio. So these are really good tools. They're called trig tools, and they only work for right angle triangles because you have to have a 90-degree angle to have a hypotenuse. Okay, if you don't have a right angle triangle, you're not going to be using this lesson or the last lesson. These three trig ratios only apply for right triangles. Okay, now you might say, well, what if we knew all three sides and I just wanted to know the angle? Well, then you've got lots of things at your disposal. You could use any of the three trig ratios if you knew all three sides. But a lot of times you're only given two and you have to find the angle, or maybe you have to find a side and you only know one side, another side, and the angle. So sometimes it's dictated to you which one you use, and sometimes it's a choice. Okay, so let's do some examples. Find the three primary trig ratios for theta. Theta is the angle in the corner. Remember, that's the Greek letter theta. Express the ratios as decimals rounded to 4 places. Okay, so get your calculators all working. Okay, so just a reminder, there are units for angle measurements. So we always use degrees in this course. In grade 12, we practice using other units. So you have to make sure everything's in degrees. So my calculator is it's an iPhone. The fact that this button at the bottom here, RAD, is showing means it's in degrees. If I press that, it shows rad, and you can see this button change to degrees. You want to change it back. Now, unfortunately, they don't put the DEG at the top, which I've never really understood. But your calculator, you'll have something at the top, either degree, RAD, or DRG. You're looking for that first. If you have the wrong setting, all these calculations will be wrong. Okay, and it's very frustrating. Okay, so what do we want here? So for the first triangle, there's the angle of interest. Okay, they want us to do this for this angle, theta. So the first thing we do is we label the sides. So the obvious side all the time would be the hypotenuse. Okay, that's opposite the 90. The next obvious would be the opposite side, which is opposite the angle. And then our adjacent side is next to the angle. Okay, so I'm going to do all three ratios. I'm going to do sine theta, I'm going to do cos theta, and tan theta. Okay, so remember, Sohcahtoa, SOH, sine is opposite over hypotenuse. So opposite 10 over 26. Okay, maybe I'll just do the decimals at the end just to make sure we get the fractions here. Cosine theta, ca, C-A-H. So that means I want adjacent over a hypotenuse. So that's 24 over 26. close together. And tan theta, which we did last time, opposite over adjacent, TOA. So O 10 over 24. Okay, so now what we do is just use our calculator. 10 over 26. Okay, so for rounding, we want 4 decimals. So up to the 6, we look at the next decimal. Does it go up or down? Does it go up or stay? It stays. So 0.3846. Okay, the next one, 24 over 26. 0.9231. And then the tan ratio, 10 over 24, 0.4167. Okay, so that's what they're looking for there. What are the ratios of these three what are the decimal equivalents of these three ratios? Now, I'll be honest with you, these don't actually mean a whole lot. Okay, that's just the ratio of one side compared to the other side. Okay, now where it comes in useful, we'll practice this next. If we took sine inverse of this number, or if we took the cos inverse of this number, or if we took the tan inverse of this number, we would get the exact measurement of theta. So we could actually get it 3 ways. Those 3 calculations would be the same answer for all 3. Okay. So if you're looking for just that angle, we don't really have to do all 3 of these. We'd only do one and then do sine inverse and get the actual angle. Okay. But they asked us for what are these 3 ratios to see, just to get practice in doing them. Okay. So the next question is the other triangle here. Now these triangles, this side lengths here are in centimeters. And again, theta is there. So don't be fooled. Like, I could just spin these triangles around and then the sides are in different places, right? So you always start from scratch. So opposite the right angle, that's the hypotenuse. Opposite the angle, that's opposite. And then over here, that's adjacent. Okay, so do the same exercise. Sine theta. So sine is SOH, so that's opposite over that, over hypotenuse, 6.4 over 7.6. And you notice I'm not putting the centimeters, that would just mess it up. Okay, well, we'll figure what that is later. Cosine theta is, so cosine Sohcahtoa, Ka, C-A-H, adjacent over hypotenuse, 4.1 over 7.6, and then tan, opposite over adjacent, 6.4 over 4.1. Okay, so let's do some decimal equivalent. 6.4 divided by 7.6, 0.8421. 4.1 over 7.6. 0.5395, bumps that up. And then finally, tangent, 6.4 divided by 4.1, 1.56. Okay, now this is an interesting one. So looking at 9, do I bump that up? Yes, I do, because that's a 7. So that bumps up to a 10 or a 0. Let me do that again. 6.4 divided by 4.1. Okay, so that bumps up to 1.5610 because the 9 bumps up. Okay, all right. So there's our 3 trig ratios for triangle B. Now you might look at this and go, how would I know if these are right? Well, for 2 of them, the sine and the cosine, you can actually know possibly if you did something wrong, Because if you think about it, you always know the hypotenuse has to be the biggest side, right? So so the sine and the cosine both have the hypotenuse on the bottom, right? So if I ever got a sine or cosine ratio bigger than 1 or bigger, that would tell me something went wrong. Either I put the wrong formula or the wrong value in the formula. So these 4 values all have to be less than 1, okay? And they all are. So now the tan ratio, anything goes, right? Because opposite over adjacent, you never know how big one side is compared to the other. So it could be really small. It could be big. It could be much bigger than this. It could be like 7 point something. Okay, but the sine and the cosine, there's a way to know if you did it incorrectly. Okay, so this time we've got sine 26. We want to convert this into a value. So sine 26. So this is just practice using your calculator. Okay, so like we did this with the tan. Okay, for me, for the iPhone, we entered the degree first. So I would enter 26. Make sure you're in degrees, of course. 26 and then the sine button. So right now, I guess I pushed a button. I've got sine inverse there. I don't want that. So I change it back to the second function I turn off. So now it's back to sine. So 26 and then sine. And it gives me one of these decimal values again. 4.4384. Okay, and you can see these are in the range of some of these. And then cosine 75, same idea. You press 75 and then the cosine button. 0.2588. Now the interesting thing here, if I took that number and did sine inverse, I would get back to the 26 degrees. If I did cos inverse of this, I get 75. So it undoes the cosine and the sine functions. Okay. All right. Lots of word problems with trigonometry, but the good news is they all involve triangles, and they're not all that difficult in terms of the math. Okay, so Captain Jack is navigating his ship to Port Harbor, which is directly north of the ship's location. To compensate for an easterly current, he aims for a point on shore that is 5 kilometers west of Point Harbor. Okay, so the hardest part about these is just drawing the situation. So I basically got this is the shore that the boat's trying to get to. So I'll put that's not really the shore there, but that's where the boat is at that present position. So directly across is where he wants to go. So directly north of the ship's location. So I'm going to call that, I guess, P for Point Harbor, S for the ship, and now there's a current going. I guess it's going this way. So if you aimed your boat straight across, well, the current's going to push you downstream, and you're going to end up getting to shore there. So he knows, because he's a very good captain, he knows he has to aim his boat 5 kilometers west. So this is west. This is 5 kilometers. All right, and you can see, well, I can call that X, I guess, for where he's aiming for. Now you can see I've actually formed a right triangle here with these 3 points. And the right triangle is right there because the shore is straight line and these two are perpendicular to that shore. Okay, so what are we trying to figure out? Assuming the point on the shore is 20 kilometers from his position now. So where he's aiming is 20 kilometers away. Okay, and what do we have to do? What bearing, what angle must he head his ship? So the angle we want is here. So I'm going to call it theta, to get used to using that as instead of x all the time, because we've already used x over here. Okay, so we want to figure out what that angle is. We have a right triangle, so we can use our trig ratio tools. Okay, so let's name these sides like we did before, and then figure out what ratio we should use. Okay, so there's my right angle, so directly across that side is my hypotenuse. This side here is my opposite side, and this side here is my adjacent side. Okay, so what sides do I know? Because if I'm going to get an angle, if I want to know that angle, I have to use a ratio that has both of the sides. So I need, right now we know the hypotenuse, we know the opposite side, we don't know adjacent. So I need to use a ratio that's got an O and an H. So then you go through your list in your head, Sohcahtoa, well, SOH, right? So that tells us we should be using the sine ratio. So I'm going to write this out. So sine of, what's the angle? The angle we're going to call theta, and that's going to be equal to opposite over hypotenuse. So that's 5 over 20. Okay, now just like we did this with tan in the last lesson, basically what we're doing is we're taking the sine inverse of both sides. You don't have to put this step every time, but it's good to know what you're doing here, because I think a lot of people think, oh, you just move the sine over to the other side. No, you don't do that. So we're taking the sine inverse of the left side is equal to the sine inverse of the right side. Now what happens here is the sine inverse and the sine function, those are opposites. Those are inverse functions. They undo each other. So basically all we're left with is theta equals, I'll just write this again, sine inverse. If you wanted to, you could reduce it, but let's just leave it for now. And now we do our sine inverse function. So again, this depends on the type of calculator. Now, most of the good calculators, you can see the word sine inverse. You would put that in first, and then brackets, and then the number. So in my case, I have to put the number in first, then sine inverse. So I have to figure out what 5 over 20 is. So I do 5 divided by 20. That's equal to 0.25. I want to take the sine inverse of that. So I go over, I want to do second function because I want sine inverse. Second function, sine inverse. So that gives me 14.477. 14.47, and they want it rounded to, well, I guess it doesn't say there, but usually for angles we'll round to the nearest degree, so this would be 14 degrees. Okay, so therefore Captain Jack must head his ship 14 degrees, and we could say he's aiming it towards the west. We already kind of knew that, 14 degrees west, because if he aimed at 14 degrees east, he'd be way off, because that's where the current is pushing him anyways. Okay, all right, second part of this, same captain. This time he's communication with a submarine that's cruising at a depth of 400 meters below sea level. Jack's radar tells him that the submarine is 500 meters from Jack, due north of his ship. At which angle is the submarine located with respect to Captain Jack's ship to the nearest degree? So again, we're going to draw a picture. This picture was kind of a bird's eye view from above. What's going on with the ship? Where's he trying to get to? This one, because it's underwater, we're kind of doing a side view of this. Okay, so up here, that's the water level, and we'll put J for Jack's ship. Okay, now we know that the submarine is 500 meters from Jack, but the depth of the submarine is 400 meters. So if I drew a line here that said, well, this is going to be 400 meters, right? we know that the submarine is somewhere along here because it's 400 meters below below the water surface. Okay, but it also says the actual distance from Jack is 500. So the submarine's 500 meters away, but it's 400 below. So 500. So if I drew a straight line from Jack to the submarine, it would be 500 meters, but that's also 400 below. Okay, so again, we've drawn a right triangle. What do we want to know from this triangle? We want to know the angle, the submarine located with respect to Captain Jack. So that's going to be this angle here. What angle off from directly below is the ship, is the submarine, sorry. You can just call this A if I need to use it, but I won't. Okay, so again, I want to know that angle. This is a right triangle. I can use a trig ratio. This time I'm going to check what sides do I know. Okay, so again, I got to label the sides. So if that's the right angle, the 500, that would be the hypotenuse. This opposite side here, opposite from the angle, that's the O, and this will be the A. So what sides do I know? I know A and H. So what ratio uses A and H? Sohcahtoa, that'd be the cosine ratio this time. So the cosine ratio of the angle, theta, is equal to adjacent over hypotenuse, 400 over 500. Okay, so I'll skip the step here that I did, but I just want you to understand. So if we took the cosine inverse of both sides, we would end up with theta is equal to cosine inverse, 400 over 500, and you could reduce that to 4 over 5. What I don't want you to do is to do the actual rounding of that number. I only want you to round at the very end. So that's why I basically just want you to do one calculation, one rounding, one answer. Okay. The more you round, the more times you round, the less accurate your number is. So when I do the calculation, so this time I have to enter the number first. So 400 divided by 500, 0.8, which, we could have done that, but, and then I'm going to do cosine inverse. So I've already got second function on. So cos inverse is that button. And I get a 36.86, which I can round to 37 degrees. So therefore, the sub is at a 37-degree angle with respect to the ship. Okay, so all these questions you get, well, probably the next lesson as well, it all involves right triangles. Okay, so you basically do the same process. What angle am I interested in, or what angle was I given? What are the names of the sides? Which sides do I know? Then which ratio should I use to find the side or the angle that I want to know? Okay, so it all comes down to that. Go through this process. Hopefully you can translate the words into a picture. That's a real important skill that you're going to be enhancing over the next couple of years in high school, but you always know it's going to be a right triangle. So in this case, okay. So I've got some questions there for you to try out. There are some word questions here, 15 to 26. I'd like you to just try a couple. I said 5 here, but just have a look at those. We'll be coming back to other word problems in the next lesson. Okay? All right. Have a good day.